Hello, everyone. We're just going to give another minute or so for people to pile in. All right. So thank you for everyone for joining this QPS and Chesapeake joint webinar. This was a development that was brought to us by some joint clients between QPS and Chesapeake, asking how we might be able to increase efficiencies between our two workflows. So this is a collaborative effort between us. This is now working in the field on multiple different projects. Actually, the data set you will see today, which was collected by our joint clients, the National Oceans and Applications Research Center out of Mississippi, is a project that was done using this workflow. We also want to thank ASV Global. This was a project that was completed with an ASV that was outfitted with an EdgeTech 6205 system, as well as an Applanix POS MV. So just quick housekeeping, if you have any questions, please type them in the question log. We will have time for some live Q&A at the end. But for now, I'll do a brief introduction. My name is Evan Martzell. I'm the Sales and Business Development Manager here for QPS in the Americas. I'm joined by my lead Senior Sales Representative, Marcus Kwasek, and of course, Harold Orlinsky of Chesapeake Technology. So I'll let Harold say a brief intro, and then we'll get into it with Marcus in the demonstration. Thank you.
Thanks, Evan. Good morning, and thanks for attending today's webinar. I hope everyone's doing well. We've had a lot of issues, but hope everyone's doing well. And you're ready for today's presentation we've prepared for you. It lasts 45 minutes or an hour, and feel free to ask questions. Send us questions afterwards if there are anything. During my session, I'll show off how we're going to take the raw data files and go from a few of the processing techniques to get to a final product. It's a quick session only because there's a lot to show, but again, if there's any questions, feel free to contact me, after the webinar. So with that, I hope everyone enjoys today's workshop. Thanks.
Thank you, Harold. Well, we're gonna go ahead and start with the whole entire workflow, excuse me, starting with Qinsy acquisition, and then we'll go into processing the bathymetry straight from Qinsy into Chimera. From there, we will also go, we'll switch over to Harold, who will go through Chesapeake. And then once we're all done, we will do bring everything back into Fledermaus. Okay. The overall presentation is going to be about 30 minutes or so. At the end, we will have a small little poll that will only take about 45 seconds or so. And one of the first question in that poll is going to be if people are interested in evaluation licenses. So if you are interested in that, we can take care of that. If for some reason you have to leave beforehand, you can also type in eval into the Q&A. So that's also an option for you as well, okay? I'm going to go ahead and start our presentation. If you guys have any questions, please feel free to let us know.
Starting with acquisition, we can use QPS's Qinsy navigation suite to collect both the bathymetry and the side scan data at the same time. In this example here, I've got various displays set up that allow for easy visualization as well as QA/QC of the data as it's coming in. For example, on the left side of the screen, you see that I have a swath display. This provides us corrected bathymetry data of both the port and starboard transducer. I also have a custom generic display that I've enabled the visual of ASCII data for the easting, northing, heading angle, crab angle, speed over ground, as well as the depth below the transducer. I personally also like to throw in a solution mode tag in there just so I can see what solution status my GPS was in at any given time. In the center, I also have a navigation display here. This allows us to visually see the actual sounding grid that's being produced live from the incoming data. Right now I have it showing the bathymetry data, but we can also click this drop down and easily switch between both the bathymetry, a beam average, as well as a time series or even the side scan data as well, just by selecting something. For example, I click beam average, now I'm looking at the actual beam average layer. Switching back to bathymetry, we can also look at any sub-layers within each of those data types. For example, with the bathymetry, I have mean value, my minimum deepest values, my maximum shallowest. I have a hit count, as well as a 95% confidence level, again, easily chosen from the drop-down menu. Down at the center of the screen, we also have a 3D point cloud display. Here I've got a loaded little 3D model of an ASV here, and here you can see all the points that are being produced by the multi-beam as I'm recording. This is just another way of visualizing your data, maybe even take a look at some artifacts that are present there. On the right side of your screen, you'll see that we have a water column display for a waterfall display for our side scan data. The nice thing about this is we can easily switch between our low frequency and high frequency. We often see sometimes users will have two separate waterfall displays so they can both see the low frequency and the high frequency at the same time. But since this ASV has the transducer up at the surface, our high frequency is not collecting as much data, so I'm just going to have that one minimized. One thing I like to point out with the side scan waterfall display is that we can easily pick targets as well. So using the target pick tool, I can draw a shape. And once I right click and I click save target, this will open up our save target window. From here, we can easily give this target a name. So we can just say, we can just call this debris to be generic, and go ahead and click OK. And now, not only will I have that target visually available for later use, but it's also on my navigation display available for any kind of visuals for later use. Nice thing about Qinsy acquisition is that we can record all of this data to one database file. The benefit of this is it provides more efficiency for processing later on, as well as reduces the volume of data that's being recorded. So you don't need to record those other file types of any third-party software. You can also produce a dynamic surface in the background, which can also increase the efficiency of going from Qinsy to Chimera processing. Next, I'm going to go ahead and move over to Chimera, and we'll go through the processing of some bathymetry data. Once you are done with Qinsy acquisition, you can easily access your project in Chimera by going back to the Qinsy console and pressing the Chimera icon. Once you do this, it will open up Chimera and then prompt you to select your license if you have more than one. And then you will be prompted to go ahead and open up your project in either a point cleaning or a full processing session. Point cleaning session will be only used for just doing initial point cleaning. You're not going to be able to import any additional navigation files. This is the same situation if you had a Chimera clean license. Full processing is as if you had a full Chimera license. You can apply additional navigation data and anything else for additional ray tracing and or ways to improve your data. So I'm going to go ahead and click full processing. Now Chimera will go ahead and automatically pair my DBs and QPDs and import the data accordingly. Once your lines are loaded, you can now see that our guided workflow at the top is prompting us to create a new surface. And that would be a dynamic surface. Again, just a reminder, if we had recorded a dynamic surface while online in Qinsy, this would have automatically imported when we opened up this project, and there would be no need to create a new surface. So I'm going to go ahead and create a 50 centimeter surface of this data set. Now that our surface is created, we are ready to import any auxiliary data, including SVP casts and or tide data, and then begin cleaning. For example, if we wanted to add a tide station, we could do so quite easily by going to the source dropdown, clicking Add Tide Files, select our associated ASCII file, go ahead and make sure that our data is parsed out correctly, which in this case it is. I've identified that I'm using the verified column as my tide source and the first column being my time source. Go ahead and click OK. Next, we need to create a tide station, so I'm going to go ahead and click Add Station. And we'll just go ahead and call this tide station for this example. Here you can set the coordinate system. This is all meta information. It's good information for later use if need be. We can give in our latitude longitude position. So in this case our latitude is going to be 30 degrees 0.325. Longitude is going to be minus 89.325. Check your time zone and check that your current unit and the positive upward or downward option is correctly applied. Click OK. Now you can see that we have these settings now available. Go ahead and click OK, and we'll go ahead and import the tide file. Now you can see that all of these files are now flagged to be reprocessed. We can go ahead and reprocess these files in order to apply the tide station. You can also see that the tide station is being applied by selecting the files, clicking processing settings, and then going to vertical referencing, and now we have tide enabled. Now that we've applied any additional data formats into our files, we can now go ahead and begin the cleaning process, whether through filters and or any of our various editing tools. For example, I can use a rectangular select, open up a slice of my data, and use our slice editor tool. And once we have it loaded, we can go ahead and begin cleaning by using any of our selection methods. For the sake of time, I've gone ahead and switched over to a project that is already cleaned. Once you have finished all your cleaning or running any filters, you do have the option to export your dynamic surface as other deliverables if that is something you're interested in doing. You can highlight your dynamic surface and go to Export Dynamic Surface, and you can choose from one of our many options here. If you're looking for a standard XYZ, you would choose the Export Surface option, and this would export your gridded surface to either an XYZ format or any of these other options as well. For example, a floating point geotiff if you're looking for the image with its associated Z values per pixel. If you're just looking for just an image, that would just be Export Dynamic Surface, Export to Image. Also, some people like to ask, how do I export to individual soundings for every single point used within a surface? That's done through these Export Soundings options. I'm now going to go ahead and cut over to Harold Orlinsky with CTI. He's going to go over how to process the side scan data that we collected with Qinsy. Harold?
Thank you, Marcus, and thank you, Evan. I'm Harold Orlinsky, Chesapeake Technology. This section of the webinar will be working on the Chesapeake side Sonarwiz for data processing. A long time ago, Aristotle once said that the whole is greater than the sum of its parts, which is probably true in this case. We're looking at QPS for the data collection, Sonarwiz for some of the data processing, and we're going to go back to QPS for some data visualization. How we're going to do this, we're going to import this QPS DB files and paired QPD files directly. No conversion needed, streamlining the workflow. We're going to set up a project in Sonarwiz, set the geodesy as needed. We're going to bring the side scan data in, bottom track, gain, colors, adjustments needed to enhance the image. We're going to export the geotiff. At the same time, we're going to look at some contacts and capture them and do a few reports. In the side scan workings, some of the images I'll show would be the target capture, the digitized view, and then I'm going to take this entire geotiff image and export it out to Google Earth. So let's get started. The data itself, when we're finished with it, will look like this. But how do we get to an image to this extent? Well, we're going to take that off, and we're going to start with importing our files. And I'm going to bring in 5 QPD DB files. It only shows QPD, but we need that paired DB file as well. In the advanced settings, just because in this case it's a fixed mount system, we want to make sure that we have sensor heading as opposed to course made good. We're going to get the best heading out of it. I'm going to choose channels 1 and 2. Alternatively, I could have used channels 3 and 4 for the high frequency. The data comes in, takes a few seconds, and there's our data. First thing we notice is the data doesn't look good. There's a bottom track issue, there's a gain and colors issues. We want to try to fix these things up. I can go ahead and start with my bottom track. It's a little tedious because we want to make sure that this blue line touches the first return. And there's some settings I can use up in here in terms of an offset and some threshold. I'm going to hit apply and track. And it follows along a pretty good job. Well, when you have a lot of files, we want to do it in a batch mode. Again, we want to streamline this process. So I'm not even going to save that bottom track, but I'm going to go in up on top and do the batch bottom track. I'm going to use those same values that I had. I'm also going to add in a 1/2 meter offset to drop the seam a little bit, the connecting part, just so that it looks a little bit better in the mosaic. And I'll track selected. And this goes through the 5 lines and all the data has been bottom tracked. We still want to make sure that the bottom track is okay, so we can give it a quick visual to make sure that the blue line, that first return, has actually found the bottom. And a couple of seconds we can go through all the lines where we don't have to worry about digitizing everything. That automatic way of bottom tracking did a really good job. But we want to make sure that any of the fish or any of the stuff in the water column didn't get captured by mistake. For instance, in this case, one little fish, I'm just going to remove that one point, top to bottom, and what I'm doing is I'm interpolating across the 2 good side of things. Apply and go to next. In this case, the threshold was a little bit high. I could change my threshold or just remove these points from top to bottom and clear it up that way. And that gets me my bottom track for everybody. Let's zoom out a little bit and see everybody. That bounding line is just the line that I'm highlighting right now. But I want to take a line, doesn't matter which line. I'll take a single line and I'm going to just isolate it and say, this is the one I really want to concentrate on. I want to clear up the gains and make sure that things are going really well. So I'm going to go into my settings and my gain settings, and there's different ones. There's BAC and AGC and TVG, an alphabet soup of gain settings. In this case, I'm going to use EGN, and we can look at all the other ones and see which one is best, but in this data set, I believe the EGN will be the best. I'm going to select all the files. I'm going to build a table of all the files and come up with an empirical gain normalization. It takes a few seconds. Once we have this table, we don't have to rebuild it. And I'll put a little destripe filter to do the along track cleaning up as well. Once everything is set, I'm going to say OK. And if we look at our data, it looks pretty good. If we compare it to the neighbor's line, that's what we started with. We also notice that at the edge of the beams, maybe we don't want to have the full swath. The swath is the entire swath is a 100-meter swath, so it's a 50-meter range scale. But maybe there were some thermoclines, maybe not in this data set, but maybe we have some thermoclines. We want to remove some of the outer beams. We have this trim data where we can trim it, the adjust display range. Rather than do 51 meters, I'm going to go up in here and say 45 meters. Just a little bit off the edge. If we had a tremendous amount of overlap, we can clean it up that way as well. But again, we have all these data sets, and I don't want to do that same thing over and over again. So I'm going to take the line that I worked on that I think is really good, and I'm going to make like others. And there's EGN, there's display range. There's different items up there. We can select each of them on, but we know we only did those 2 items, so I'm going to cheat a little bit and say apply all settings. And we'll say OK. So remember what we started with the no track, no bottom track, and colors all over the place? Well, this is where we're coming to a little bit better. We look at our colors. We have our bronze color or MSTL bronze, where we can go to a grayscale. Traditional is where I learned side scan. We can invert the colors if we want. We can be grayscale or any of the colors and manually set the threshold, the color palette. Looks pretty good, but we're going to go to the auto, and let's go back to MSTL bronze. That's just the one we've been using for a while. We have this line in the middle. It's highlighted. What's happening underneath? Well, we have a little bar up there where we can swipe it out, and I can slide it back and see how it compares to the other lines. It's a nice way of verifying that the data is matching well. The idea about side scan Mosaic is to be able to export this data out. What you see on the screen is what you're going to get out. If we zoom in too close, then we're only going to get that portion, but we're going to get this entire image out. So my processing export save to geo image, I'm going to save a 1/2 meter mosaic, and I'll label it 50 centimeters. 50 centimeter export. I want to launch the viewer after I'm saving just to see what I can, what we're coming up with. It takes a couple of seconds depending on how big the file is. This one takes about 15 seconds. Come up with a mosaic that's a georeference image. We did this for the entire 30-line data set, and this is what I'm going to pass off to Marcus in a few minutes. But that's our georeference image. What happens if we only wanted a certain section of this mosaic or this data set? Well, I can certainly go ahead and add a feature. I'm going to add in a small little feature around this one little section, and that's the only area that I want a mosaic. And something that's interesting out there. I go back into my export. In this case, instead of a do not crop, I'm going to export it against that feature, and I'm going to call it clipped. Again, 1/2 meter. I can go any resolution I want. I can do 2 centimeter resolution. Problem is you're overdriving the side scan at that point. So I'll do 50 centimeters and I'll export out, and there's my data image. So whatever you want to see, you can export out. Don't need my feature anymore. What about one of the other things that we do besides making a mosaic is we're going to look at a file and we're going to say, well, are there any contacts on this file? So if I digitize new feature view, I can show slant range corrected or not. But there's my scour marks for my drag arm. And I go down, there's a feature. There's a rock. I'm going to mark the contact. If I go to the next line, that contact, if it was overlapping, would show up. At some point, there will be another line that matches up. I believe this one has the contact right there. So the contacts can be correlated from line to line in this digitizing view. If I look at my contact itself, I want to measure how big this contact is. There's my contact. Let's zoom in a little bit. First off, if I didn't like the position where I marked it, I can always move the contact. I'm going to move it slightly to the south. I'm going to measure the length from top to bottom. And I'm going to measure the width from left to right. The shadow height In this case, because we're color is going to be the black area, I'm going to be that high. So I'm measuring it at 47 centimeters. And we'll say okay. If we look at the other line out there, this far line, and let's do the same thing on this digitizing view. There's my contact. I'm going to mark it right there. And I double click on it and I zoom to the a little bit bigger, the length and the width. Length and our width and the shadow height. 51 centimeters. So side scan isn't a precise science. It's not like multi-beam. We're going to get close. I had 47 centimeters on the rock height on the first one and 51 centimeters on this one. It's pretty good. But one of the problems we have with side scan is sometimes the position isn't that great. In this case, that's the same rock. They were just, it shifted a little bit. I can turn there's the first rock up on top, and there's the second rock on the bottom. And which position is correct? I don't know. But I could take the two contacts and say, well, I'm not really sure which one is correct, but I'm going to rationalize the positions. And I'm going to come up with a position that's the center of the two, the best I can come up with. And I can do the same thing with the target and the reports. If I want to do reports, I want to take my contacts and open up my contact reports. And let's see what the contact reports would look like. I'm going to use my contact reports and generate a PDF document. You can make an Excel document, an HTML, but I'm going to make a PDF document. There's my first contact, and there's my second contact. So we can start seeing a lot of information. One thing to note is that there's a little dot on it, which you may not want to see on your contact. We'll just go into the contacts and not draw the symbol, and that's as simple as it goes. So what do we do next? We have all our data files coming in. I have, in this case, just the 5 lines. But we want to bring out all the lines. And in this case, I have the entire data set exported out to the GeoTIFF image. And from here, I'm going to pass it back to Marcus, where he's going to take this one file and do a bit more on the visualization. Thank you.
Thank you, Harold. Just to recap, we've gone over the acquisition of the bathymetry and side scan data in Qinsy. We then went straight from Qinsy into Chimera for processing the bathymetry, and then Harold took over and showed us processing of the side scan data in Sonarwiz. I'm now going to go ahead and show how to visualize all of this data within FlighterMouse. And to do that, I'm just going to go ahead and open up FlighterMouse right now. Now, one of the nice things about when you open up any of our QPS products is that we have this QPS project browser that pops open, and it'll automatically recognize what was the last QPS project that you had open. And as you can see, it's showing that I have this Chimera project that we were just working on. So I'm going to go ahead and click open. And once I do that, it's going to go ahead and load in any file that was in the directories located within that project. So as you can see, it's got all the QPD files that were used in it, as well as our dynamic surface, the sounding grid that was created in Qinsy, any CAD files. So these are actually our the waypoints that could have been created online, or any annotations that we made. We also have the image files, and these are actually the GeoTIFFs that I went ahead and grabbed from Harold and put them into my graphics folder. So from here, I can easily just click on an object, right click, and go add to scene. And it will immediately load in that object into FlighterMouse, and you can see it pop up here on the left side. So there I've got my final dynamic surface available here within FlighterMouse. I can also load in the QPD files, so this will allow us to see all the different soundings within each of these files. So I can again right click on the QPDs, click add to scene, and it'll go ahead and load those objects in. And once they're loaded, we'll see them pop up again over here within our scene objects. So once I've got objects loaded in here, I can easily turn them off and on by just enabling or disabling the associated checkbox. One thing I like to do when I've loaded in a bunch of QPDs, I like to highlight them all, right click, and click create group from selection. Then I can just maybe make a group labeled QPDs, and now I've got a little subgroup with all of those files in it. So I can just easily turn them all on off with just one checkbox now. Next, we'll go ahead and import those geotiff files. Since I add them to my Qinsy project and Chimera project, you can see that since I have those available here, I could again do the same thing, just right click it and add to scene, import image to my scene. We could also import it from the import drop down, go to import image, and then we could go to that folder and grab the file from there as well. But for simplicity's sake, I'm going to go ahead and just choose import image from our project directory. Once you've selected your file, you'll be able to see that it's going to provide us with this information here where you need to define your coordinate system that the file is in. As well, it will try to extrapolate the entire range, assuming it's in this coordinate system. I'll go ahead and click OK, and it'll begin the import process. Once the geotiff is loaded, we can easily turn it off and on just like we could with any of our other file types. Next step we'd most likely want to do is to drape our geotiff image on top of our surface. To do that, we can highlight our surface, right click and go to operations. We can click drape image. Once you click this, you can either choose a file from your disk, although since we've already added this image to our Fledermaus scene, we can use the loaded image option here and click OK. Once the draping has finished, you'll now see that we have a new option available once our dynamic surface is highlighted. I can have my draped image visible, hidden, or I can have it visible with shading, which will allow any shadow effects. So now when I zoom in on this image, we can see that now there's actually a three-dimensional aspect associated with my geotiff. To better see this, I'm going to go ahead and increase the vertical exaggeration, excuse me, and this will allow us to see that a little bit better. So again, I can easily turn this off and on just by switching to different formats. I'm going to go ahead and add in one more image to the background. Again, I can do this from the import image dropdown. You also see that I've got a survey area TIFF here as well. I'm going to go ahead and import this image to my scene. Now that I have that image loaded, I can go ahead and zoom out, and we can highlight the geo image in question. I can adjust the transparency as needed if I want to take a look at an object. I can also compute a mask of this image if I want to be able to cut out an area where our data is actually going to be. In order to compute that mask, all I need to do is just make sure I have the other object I would like the image to be masked from. I'm going to go ahead, right click on the image in question, operations, compute mask. I'm going to go ahead and leave the name of this new file as default with the compute mask option in it. Go ahead and click OK. Once the mask has been computed, we can go ahead and turn off the other geo image, and now we can see that there is a cut hole where our data actually was. I'm going to quickly press this icon here that will zoom to all of our loaded data. Once you have everything loaded into Fledermaus that you would like to have loaded, you can always share this scene with all its associated objects that you have loaded within your scene objects doc with somebody else, whether it's a client or another coworker, by going to File, Share Scene. Now what this does is it actually zips up all of the different objects within the scene objects into this QSZ file, which can then be sent to somebody else and then opened with either another Fledermaus license or with our free Fledermaus viewer. And then that person can just explore around with this exact data set. You can also do another analysis within Fledermaus at this time, whether you want to do some slope analysis or you want to do volume calculations, create some contours, whatever the case may be. And that concludes our demonstration for Fledermaus.
Okay. Okay. Thank you, everybody. That was the end there. I'm actually going to go ahead and start with our polls real quick before we get to the Q&As. Starting with the first poll. Are you interested in a Sonarwiz or QPS evaluation? This includes an evaluation license that we can send to your company so you can test things out. If you go ahead and choose an answer real quick, then we'll hop over to the next question. I'll just give about 10 seconds or so.
And for some reason, if you don't get a chance to vote here, by all means, you could easily just type in the questions you'd like an eval, or feel free to contact either myself or Harold directly. We'd be happy to supply one.
Okay, we'll switch over to the next question. Are you currently a QPS user? And so this would include anything from Qinsy, Chimera, Fledermaus, Cordocaster, anything of the sort. Okay, go ahead and close this one down here. And our last poll we have is, are you a current Sonarwiz user? Let's give it a couple more seconds. All right. Thank you very much for taking the time to do that. I'm going to hand it back over to Evan, who will go over some questions that we had during the presentation.
Yes, great. Thanks, Marcus. And I just want to remind everyone as well that this this webinar is being recorded and will be posted on our website, QPS's website, as well as Chesapeake's website. So in case you missed it or were late, we will be sharing this after we get the full video. So we do have a handful of questions here, some technical ones and some business related ones. So I'll take a few of these. First, business related ones. He said, is there an upgrade path for existing users to either QPS or Chesapeake? So yes, there is an upgrade path. If you are interested in testing out this workflow, you can either contact myself or Harold. Our contact information was available in the beginning there, and we would be happy to get back to you. We do have your contact information during the webinar, but if you are, please just type in pricing or something along the sort to the questions, and we'd be happy to get back to you with that as well. And that is one of the other questions here, is how do we get pricing for this workflow? Again, please feel free to reach out to myself or Harold. We'd be happy to supply pricing. We do a joint pricing, and we'd get back to you as soon as possible. Okay, I see here, Marcus, there is a couple QPS related technical questions. Do you want to take those?
Yeah, we'll go ahead and grab that. The first one I see is, how long did it take to roughly process the bathymetry? Between import and applying the tide files and the processing and then actually doing the cleaning, I did most of the cleaning actually using some of our 3D filters and spline filters. And then I would only had to do really some spot cleaning here and there where there was some extra noise in the data, whether it was from air in the water column or whatever the case may be. Overall, it's about 30 to 45 minutes total. So that's a great question. And I see another question here. What is the best method to obtain a survey area geotiff? I personally, you can do it from a number of different places. You can either take a screenshot from Google Earth and then you can geo-rectify it yourself. I like to use Global Mapper to do that, which is quite nice. They have it on. They link directly to the online databases. There's also various online databases that you can use to download the geotips of a certain area as well. Okay, good question. I think the rest. The rest is mostly for Sonarwiz, it looks like. I'll hand those over to Harold.
Thanks. I'm reading and answering at the same time. Just to one of the questions folks always have is how long does it take to process the side scan data? And I did a couple of time tests here, and depending on how quickly your computer is, this data set took me about 15 minutes to make a Mosaic. Because it was a batch bottom track and the gain settings was the EGN. So about 15 minutes on my end to the mosaicing side of things. One of the questions I see is do you need the DB files once you import it into Sonarwiz? And the answer is no. We're going to make our CSF files, which has all this information. Tagging off, we have the sound velocity and offsets. We grab all the information on import. So I don't throw away the files, but we just don't need it anymore on the Chesapeake side of things. Another question that came in is, can you fix the navigation spike? Yes, there's a program called ZEdit. Terrible name for a program, but there's a program inside that ZEdit that you can adjust navigation, X, Y, sound velocity, if you have spike in your sound velocity. It's a simple program to use, and it opens up the CSF file, reads that portion of the CSF file, updates that one section, and saves it back. We recently added a batch way of doing it. So, if you wanted to put a min-max filter for sound velocity, for instance, you bring in sound velocity and you don't want to look at each file. You bring them all in, say the minimum sound velocity is 1460, and then run through it all. Can you import targets made in Sonarwiz to FleeterMouse? I can certainly export out contacts. That's a question to Marcus. What flavor does he want? But I have a half dozen ways of making target export out, simple XYZ, CSV. FleeterMouse likely can take it in. And Marcus, I would ask you, have you imported, you can import different contacts into FleeterMouse?
Yeah. When it comes to FleeterMouse, you can easily import any ASCII-based file system, or if you got DXF, DWG shape files, whatever the case may be, FleeterMouse can take in a manner of different file formats. So depending on what you have, that's also available.
Okay. Can you export from, I'm just reading it live, give me a sec. Can you export from CSF to XTF without the DB files? Yes. Once it's in Sonarwiz, the tools within Sonarwiz, the CSF to XTF are there. Like I said, once the import has come through, and you saw how long it took to bring the files in, we don't need the paired DB QPD files. Be careful when on the import, it only lists QPDs, but we definitely need the DB associated files. They just have to be in the same directory. I think we put a little smarts that if it's not in that directory, it looks one directory over, but it's best practice to put them in the same directory. One of the questions I see once in a while is, we've done this work for the side scan. What about the next, bathymetry and sub-bottom? Well, bathymetry, no, that's the Qinsy part. But one of the things on our roadmap this year is to handle the sub-bottom aspect for the DB QPD files. It's in the pipeline. There's no date yet, but that would be the next one. But right now, anyone that has the DB files for bathymetry, we can't bring them in. The only way would be have it exported as an XTF file, and then we can handle it that way.
Yeah, and actually, if you're recording sub-bottom data within Qinsy, you're going to be recording a SegWi file in real time, so you would be able to bring it in that way into Sonarwiz as well, I assume.
Yeah.
So I guess we want to briefly wrap up by saying from a QPS side to thank Chesapeake for their participation here. I think that this will be an ongoing partnership that we're going to continue to adjust and tweak this workflow to better suit our users. Again, this was requested from joint users and to see how we might be able to increase their operational efficiency between a partnership between these two companies. And again, we're going to continue to develop to do that. So thank you again for everyone in attendance. We will leave the questions up, say, for another couple minutes. If you have any other additional questions, please type them there. Of course, if there is a question that we didn't get to on the live webinar, we will get back to you as soon as possible. And again, if you have any other additional information you're interested in, feel free to type it and we will be in contact soon. So thank you again, everyone.
Thank you.